Hello class, today we're going to go over a tutorial for chapter 11-1 and 2. This is going to be mostly looking at goodness of fit and contingency tables. So we're going to start with in the homework question number 3. And typically when we're trying to perform these types of goodness of fit or chi-squared tests, what we have is a table that looks like this, right? And it has something in the rows here, and then you have something based off of some kind of measurement. This is time here, so those are days of the week. And then it has the frequency of something that has happened. So here it's number of fatalities, and it's talking about number of fatalities as a result of car crashes, and asking is there a difference in the frequency of car crashes that happens dependent on days of the week. And so when you look at the data right here, you can see that it seems to be that on Saturday and Sunday and Friday, there seems to be a higher frequency of car crash fatalities than there are Monday through Thursday. And in order to be able to confirm that statistically, or to have some certainty that that is the case, we perform a chi-square test. And so the way that we do that in StatCrunch is we'll go ahead and load the data into StatCrunch. And here you can see it's now looking at a day and number of fatalities are in the column here. Here's day, here's fatalities. What I'm going to do is I'm going to go to Stat, Goodness of Fit, chi-squared test. Okay, I'm going to select number of fatalities as my observed. And I'm going to then select, so it had an option here, what did it expect? We expect it to be equal across all days. That is our kind of null hypothesis, that fatalities occur with the same frequency on different days of the week. And so we'd expect that pretty much if we continue to collect over time, we would see kind of on average that the frequency that of crash fatalities occur is equivalent and independent of what day you're looking at. Okay, and so we'll go ahead and compute. And here it gives us what our expected would be. Here's what our observed is. So these are the same data as what we had in our original data here. And then the expected is that we would have 119 fatalities per week. And then basically did this by summing up everything in the observed, dividing it by 7, the number of rows that we have here, and saying that, okay, we would expect to see 119 fatalities per day of the week. All right, and then gives us a chi-square test, and the test statistic here is chi-square, or this kind of, it looks like an X with the square superscript. And the chi-square statistic is very high, 32.705. We round that to 32.706. That's the correct answer. The p-value, our significance level is 0.05. The p-value is much smaller than that. So we're going to reject our null hypothesis here and accept that, yes, there does seem to be a different frequency of fatalities on other days of the week. And then we can put in our p-value here, round to 3 decimal places. I'm just going to go 0.000. That's good. It'll give you this regardless of whether you do 0.000 or 0.001. It gives you kind of a little leeway there. All right, so hopefully that's pretty clear. Now we're going to move on to another question, question 11. And this one looks different now, okay? Before, when we had the data like this, right, it was in kind of columns and rows that we could kind of look at things very easily. Here we have multiple cells. So we have here, how would we really be able to transform this? Putting this into this type of format here isn't actually as obvious as when we did it here with the previous question. So I'm going to go ahead and open this in StatCrunch. And what we'll see here is that instead of kind of listing it longwise like it had before, it kept it as the original format. And you see here in this column it calls it var1, and in var1 it has this category of handedness, right-handed versus left-handed. And then it has the other categories here within the columns themselves. Alright, so now it's very different here. And so you might think what you'll do is go to Stat, Goodness of Fit, chi-square test, but now it doesn't quite match up to what you want to do. So you're not going to be doing that. Instead, you're going to go to Stat, Tables, Contingency Table with Summary. Okay? Then I'm going to tell you all of the columns that I know kind of make sense here. Okay, at least intuitively, var1 isn't really a data column, right? It's just kind of a placeholder for these other categories that we have here. And really remember, we're just trying to determine if the expected versus the observed value is going to be different between each of these cells. And so the cells that we're going to look at are those along the top here, right ear, left ear, no preference. And then our row labels are var1, and that's going to be looking at right hand, left hand. And this basically tells StatCrunch that I'm looking at this matrix here in this format, and I want to be able to understand what exactly is the expected versus the observed outcome, and if that is statistically different than what we would think. So here in this first question, it says use the data in the table to find the expected value for the cell that has an observed frequency of 6. And so you can go to StatCrunch and click on expected count and click compute. All right, that's all you need to do. And you can see here in parentheses underneath what was the data. Let me make this a little bit bigger so you can see it here. So it has, this is, no preference for right-handed people is 39. It expects us to be about 40.8, so pretty close. Here it's asking us to use the data in the table to find the expected value for the cell that has an observed frequency of 6. So it's this cell. We see that it is the expected value is 4.2. The problem here, though, is that something that StatCrunch doesn't do for you is that it doesn't go out to 3 decimal places. And as you can see, the correct answer is not 4.2 because StatCrunch has rounded it. So how do you get the correct answer within the proper number of decimal places you need? Well, you have to do a little bit of math. And the formula for this is in the book, but I'll show you how to do it really quick here. Specifically for this cell, but you can extend it to any of these other cells here, okay? So within this cell, what I'm going to do is I am going to take, and this is why it's good to actually do this first, because what you need to do is have the totals of the column and the row that you're interested in, right? So I need this cell, so I'm going to look at the total of the column here and the total of the left-handed here, which isn't listed here, so you'd have to add it up if you didn't do this step yourself. I'm going to multiply it, right? That's my first step here. I get 3060. And then I'm going to divide it by the total, okay? And so this simple math here is going to tell me, okay, if I have this as the total and this as the total of the column and this as the total of the row, and I divide that by the total number of observations that I have, it gives me what the expected value would be, okay? It's pretty simple, straightforward. So first I'm going to take the total of the column, multiply it by the total of the row, like I've done here, and I get 3060. And then I'm going to divide it by the total of all of the counts that I have throughout the entire matrix here, 729. And that is going to give me the long answer of 4.1975. Now, of course, as it asks in StatCrunch with all the previous questions, it says to round to 3 decimal places as needed. Here I've done that. I've gone 4.198. That's what I put in here, and that's what's correct. Okay? And so as you can see here in other questions, it's going to again ask you for statistics as you move on. I think the next one, it does something similar. So here we have a table that's similar to what we would have seen in the previous one. I'm going to open that in StatCrunch really quick. As you can see, it's the same format as before. So again, I would go to solve this problem. I go to Tables, Contingency, with Summary, put in my column variables, then list where my row labels are, in which column those are. I can click on the expected if I want. I don't know if I'll need it here. Click Compute, and it will give me my chi-square statistic and my p-value, and that's pretty much all you'll need for this homework. So go ahead and give it a shot. Remember that in this homework there's actually a lot of media that you should watch. Make sure you watch all of it, or at least click on it so that you get credit for it. And that's a big contribution to your overall grade and all of the homework, so make sure that you do that, and that will make sure that you get 100% on the homework. Alright, if you have any questions, feel free to reach out. Thanks for watching.